Hey guys, welcome back. So in the last couple of videos, we have been on the quest of migrating an on-premises architecture to AWS. We learned about the on-premises architecture and then we modeled that particular architecture on AWS within a VPC. So in the previous video, we started off with creating a new custom VPC while associating an IP range, and then we divided that VPC into two subnetworks, public subnetwork and private subnetwork. For public subnet to be internet accessible, we attach an internet gateway, and also we created two separate route tables for public subnet and the private subnet. The route table that has attached to the public subnet has an route out to the internet gateway, so that all the instances that we are going to spin up in this video will have the accessibility from the internet. But the private subnet route table did not have an route out to the internet gateway. So let's pick up from where we left off last time. Alright, now I am on the AWS console. So let's go to VPC. Just click on VPCs here. Then you should see the VPC that we created last time. By the way, if you didn't watch that video, so I'll post the link up here. So this is the YouTube VPC we created last time. For this VPC, we created two subnetworks. If I go to subnets here and filter the VPC, you can see the private subnet and the public subnet. Now I selected public subnet and I go to the route table that we associated with this. So basically you can see it is associated with the public route table, which has a route out to the internet for all the traffic other than the traffic from the VPC. Now let's select private subnet as well, but currently it is still associated with the public route table. So let's change that. So I will click edit route table association, and in the drop down table let me select the other route table, which is our private subnet. You can see when I select this one, it has only one route out to the target local, which is within the VPC. Click save. Now the private subnet is correctly associated with the private route table. Great. I think now we're in a good position to launch two instances, our web server instance and the backend server instance on these two separate subnets. So together with that, we have to create a security group, which we discussed in the previous video, is guarding the instance inbound traffic and outbound traffic, and it will control that. And similarly, we'll have another security group for the backend server that will do the same thing for backend server controlling inbound and outbound traffic. We are using the NACL that is by default associated with the subnet, which will allow all inbound traffic and all outbound traffic, which of course is not a good practice, but we'll get to that in the next video. Alright, so I will go to EC2. So we are going to launch a virtual machine. So as you can see, there's no any running instances, 0. So let's click launch instance, and I'm going to select an AMI or Amazon machine image, so which has operating system image where we can use to spin up our EC2 instance. So let's pick this one. Make sure to select one of the free tier eligible ones so it will not incur any cost. So let's select this one. Select the free tier eligible instance family type. So this is T2 micro, and I will click configure details. So number of instances is 1, and here's the network. In which network do we want to spin up this one? So this is our web server. So let's see. So our web server is in the public subnet. So let's pick our public subnet. Before that, let's pick the whole VPC, which is this main VPC. So inside that VPC, let's pick the public subnet here. Auto assign IP addresses, and we'll click enable because we want an IP address associated with our web server so we can access from outside, and leave all the other settings default. Let's discuss them in detail in upcoming videos, and click add storage. So this is the place where we allocate the storage for our root volume. So root volume is the volume that will have the operating system, in this case Linux operating system, and we'll leave 8 GB. which is a non-encrypted volume, and click add tags. You can add a tag name web server. So this will help you in finding out the cost incurred by the web server easily in the AWS bill. And next, click configure security group. So as I mentioned, security group operates at the ENI or Elastic Network Interface. Let's give a security group name web server SG, web server security group for the web server as the description. So what type of traffic do we want to allow into our web server? Since this is public facing web server, we have to allow all the HTTP and HTTPS traffic into our web server so that anyone can reach out to our public web server and view our website. So let's go to here and I will enable SSH and I will add a new rule. Let's select HTTP on the port 80 of the instance. Now this port is always the destination port. The traffic is coming from outside, from the internet into our web server onto the port 80 through the HTTP protocol. Okay, so then the source, let's give 0.0.0/0, which will represent entire IPv4 address range, and description enabling HTTP traffic from anywhere. And let's add another rule for HTTPS as well. It will allow the port 443 for all the HTTPS traffic from anywhere. What about SSH, guys? Well, of course, we don't want everyone to SSH into our web server and do whatever the things that they desire. So we will block that SSH only to my IP. So let's click my IP here, which will enable only my laptop to SSH into this web server. And now let's click review and launch. Let's review it. Well, everything looks fine to me. It will show the instance detail and the storage we attached and the tags and also the instance type. Let me click launch. And when you click launch, it will ask us to create a new key pair or use an existing key pair to SSH or remote desktop into our web server. So in this case, let's create a new key pair. So these are public key, private key encryption. So the instance will have the public key and we need to download the private key. Let's say YouTube as the name of our key, and I will download the private key. There you go, I have downloaded the private key. And now let's click launch instance. Your instances are now launching. Let's give it a second and come back to this. Alright guys, now our instance is in the running state and the status check is also passed so that we can actually use our instance. Now let's have a look at some information about this particular instance. You select the instance and if you see the description section below, I can maximize it by clicking here. You should see there's this instance ID and the state is running right now and the type that we chose, it is of T2 micro instance family, and see our web security group is also applied and all other configuration that we have configured as well as the default configurations. Now one important thing I want you to notice is this IPv4 public IP. Now if you can remember while we are launching, we specifically mention or we specifically enable getting a public IP for the instance. Now since this is our web server, we should be able to connect it from outside. Now let's rename it. I can click here, let's say web server. So the web server instance has a public IP as well as a private IP. Now if you think about the private IP, it's 10.0.0.105. Since we have launched it under the public subnet, it has received a private IP address within that range. So what is our private IP range for this particular subnet? It is 10.0.0.0/24, isn't it guys? Let's double check that. Look, I am in the public subnet in the VPC and here's our VPC range. So the CIDR block assigned to public subnet is 10.0.0/24. So 10.0.0.105 is under that range. Now guys, you can explicitly say, okay, this has to be my private IP at launching time, but since we didn't do that, it has randomly picked an IP address from our range and assigned to this. And if you look at this public IP, this is the one that AWS picked from the public IPv4 IP address pool and assigned to our instance so that we can connect to this. But one thing to remember, guys, when you stop this instance, now if you come here and go to actions and stop this instance, this IPv4 address will be released. And when we relaunch it or restart it, this instance will be assigned with another IPv4 address from the AWS IPv4 pool. If we want to avoid that, we have to assign an elastic IP, which we will look at in the upcoming videos. So now let's try to connect to this instance with this public IP. I will select the instance and I will click connect. Then it will give you some instruction how to connect to your instance. Basically, you need to have a SSH client. If you are using Windows, you can use PuTTY or else any other SSH client. Since I am using a Mac, I can use the terminal itself. And it says to locate the private key, which is our youtube.pem, and then it asks us to reduce the permission level to chmod 400 for that private key. So this is for security purposes. So what does 400 means? The owner can only read it, right? I hope you guys are familiar with the Linux permissions. Now let me give you a quick refresher. chmod 400. Now very first bit or the leftmost corner bit is about the permission for the owner, and the second bit is the permission for the group. So if you have groups, so this is the group permission, and the last one is the public permission. So what about these numbers? 1 is execute, and 2 is write, and 4 is read. So any placement value, let's say the leftmost corner placement value for the user, is a combination of these three values. For example, here it's only read. Now if you want to provide read and write, then what should be the number? 4 plus 2, it should be 6. And if you want to give read, write and execute this file permission, it should be 7 because 4 plus 2 plus 1 is 7. For the group also execution permission, it's 7 here, and for public also it should be 7 here, right? So 400, it means only the read permission for the owner. So let's quickly do that. I will take a terminal and I am in the download directory, and I should have my youtube.pem file here. Here is it. Let me clear the screen and reduce the permission of the file by typing chmod 400, that is read permission for the owner. So the file name is youtube.pem. Hit enter. Great. Now we can connect to our instance using our public IP address. So it is the same thing, 35.175, and here also it's 35.175 ending with 124. So it's the same IP address. So how do we connect to it? We can use this shsi particular command. Let me just copy this one and take my terminal and paste it in and hit enter. Do you want to continue? Yes, and hit enter. So it's adding our IP to the known hosts. Let's see if this get connected. There you go, it's connected. Can you see it says Amazon Linux 2 AMI. Now we are inside the virtual machine. Our web server starts with EC2 user. Can you see our IP address 10.0.0.105. So now we are inside our web server here. This web server is in the public subnet, and it has a route out to the internet gateway, so it can receive traffic from the internet, and also it can go to internet without any issue. So let's try to connect to internet and update some packages, shall we? Let me go to here and let's clear the screen. So I am inside my web server. Now I am connected as a EC2 user, if you can see here, because when we connect to the instance we used EC2 user at the IP address, so it is connected as the EC2 user. But if we want to like connect to the instance and get the updates, we have to increase our privilege to the root level. So how can we do that? Let's say sudo su to switch to super user. Now I am the root user. Now we can use the yum package manager of Linux to update the packages. Yum update and -y. There you go, it started downloading all the packages and we are successfully connected to the internet and receiving the updates. So now we could connect to the instance from the internet, and also within the instance also we could connect to the internet. So our security group is working fine. Knuckles, of course, it will allow all inbound and outbound traffic. And let's check our security group again. If I go to web server security group and view inbound rules, web server security group and inbound rule, you can see HTTP and HTTPS is allowed, and also SSH is allowed. So we already checked SSH. We have allowed only our IP address, my laptop's IP address. So we could connect to that successfully. And within the instance, let's see outbound traffic, and outbound traffic is all allowed. So we could connect to internet and get back the results. Now, how about if I go to outbound traffic here and remove this rule and save it? When you update the security group, it will be instantly affect in the instance. So let's see if we can still connect to the internet and get the update. I will type yum update y again. There you go, it says fail to set locale, and let's try to ping google.com. Pinging google.com, well, we don't receive any data because outbound is blocked. So let's come back to our outbound rule and edit it and re-allow all traffic outbound to any destination, and allow traffic to any destination and hit save. And let's go to our terminal again, and you can see it start receiving the ping from google.com. Excellent. Now let's try to ping our instance from outside from our terminal and see if we receive a response. So under my inbound, I have only given SSH, HTTP and HTTPS, but we have not yet added or allowed ICMP traffic. Now ICMP is the protocol that is used to ping an instance. Let me show you. If I go to edit and add rule and see all ICMP IPv4 is not yet added. So let's try to ping this without allowing ICMP traffic. Let me go back to my terminal and clear the screen. Now I'm inside the server here, but I don't want that. Let me take a new window. Okay, so this is outside the server. This is my laptop. Let's try to ping the IPv4 address. So what is the IPv4 address? This one. So let me copy the public IP of the instance and ping. Well, it is request timeout. So it is not able to ping the instance. So let's go to our security group, web server security group, and allow inbound traffic. So let's add a rule and allow all ICMP traffic from anywhere. Hit save, and now it immediately getting the response back from the instance. How cool is that? So as soon as we change the security group rule, that change will be immediately affected. Beautiful. Alright guys, so now our web server is perfectly working. So let's spin up the backend server also. I will go to EC2 and EC2 dashboard and launch another instance. Let's use the same AMI and T2 micro, number of instance 1, and the network, make sure to choose the YouTube network, and subnet, this time it has to be the private subnet because this is the database server. We don't want outside connections from the internet into our database. So that's why we put it in this private subnet. Public IP we don't want it, and leave everything as defaults and click add storage. Okay, add tags, name, DB server, configure security group. So let's create a new security group called DB server security group. Security group of the database server as the description. So now look, if we ever wanted to connect to our database server, we cannot do that over the internet because this is in the private subnet. So how can we ever get into our DB server for, let's say, update the database version or some security patches. And also, most importantly, our web server should be able to talk to our database, right? Otherwise, there's no point of using the database server at all. Web server will receive the public facing internet traffic, and from the web server, it should be able to talk to the database and query some data and get the data and return the response back to the user. So let's go to our diagram. So in the diagram, you can see this is our backend server, and we have a security group that controls traffic into the backend server. So that is the one we are now configuring. So let's allow our web server to talk to backend server. How can we do that? We can allow the web server security group to talk to backend server. So in the EC2 console, let's add all traffic from any port, not from anywhere in the world, but from our web security group. Now if you start typing web, you should see it prompts the web server security group. So as our traffic source, we can define an IP address or IP address range or a security group ID. In this case, we attach a security group ID. So what does this rule says? This rule says allow any traffic from any EC2 instance that has this particular security group attached. So in the diagram, we have our web server here. The web server has the web server security group attached. So with this rule, it will allow our web server to talk to the backend server. And if there's another server that has the same security group attached, that server also can talk to the backend server. Clear? Allow traffic from web server SG and click review and launch and hit launch. Choose the same YouTube key. So it is the same private key for us and launch the instance. Now the instance is launching. If I go to view instance, it's still launching. Let me rename it DB server. Okay, now DB server is up and running. Select that. And if you see the description, we don't have a public IP, but only a private IP of the 10.0.1 range, which is our private subnet range. So it has picked 142 IP address. So this is exactly what we need. We don't want a public IP, instead private IP. And also let's check our security group, DB server security group. And as the inbound rule, we have allowed all the traffic from our web server security group. So let's try to ping the DB server from outside using the private IP. Will that work? Of course not. Let's try that anyway. Ping. You see, you won't receive anything. This has no connection to the internet because it does not have and route out to the internet gateway, so it's totally isolated from internet. So how to connect to that? We have to connect to our web server first, and then since our web server has the security group of web server security group, it will allow to ping our database server since we have allowed all sort of traffic. So let's connect to our web server. Let me select here web server and connect and use SSHI command. Hit enter. Okay, I'm inside the web server. You see the IP address 10.0.0.105, which is the public IPv4 address of the web server. And within this web server, let's try to ping our DB server. So let's take the DB server's private IPv address 10.0.1.142 and let's try to ping that. Again, I'm inside my web server. Now I am pinging the database server IP. Hit enter. There we go. Ping is successful since we have a rule defined in the database server to accept all traffic from any instance that web server security group is attached. So what if I delete this one? So if I stop this and retry pinging, now you can't ping. See? Let me allow it. All traffic from web server security group. And if I check back, then start pinging again. So we are receiving ICMP response. Beautiful. Okay guys, now we can do the ping successfully. So how do we actually SSH into our DB instance? Let's try our normal SSH command within the web server. So I will go to EC2 dashboard and web server and pick the database server and click connect, and it will give me the SSH command. Since we have used the same private key, I can use youtube.pem, and this is the IP address of our database server. Let's copy that and come here. This is inside the web server and hit enter. And I get an error. Identity file youtube.pem is not accessible. So why is that, guys? Basically, our PEM file is not available inside the web server instance. We could SSH into the web server from our local machine inside our download folder where we had the PEM file, but once we are inside the web server, we do not have that YouTube PEM file here. Because of that, we cannot connect to the database server even if we have configured our security groups correctly. So how can we actually do that? Well, there are two options. The first option is copy this youtube.pem file into our web server into a particular directory. So within that directory, we can SSH into the database server. It will be successful. But the best practice or the security good practice is not to have private keys saved inside instances, because if somehow an attacker gets into this instance and if this private key is exposed, then you are at risk, because you might have used the same private key for so many number of servers. So all those servers will be compromised. So the best practice is to use SSH agent forwarding. That is a topic for the next video. Thank you for watching, guys. I'll see you soon.